want to look at this PowerPoint, the Chapter 4 selection structures. And I'm going to download it and open it that way. So this is the PowerPoint from our textbook. There's another PowerPoint posted that has just a little bit different point of view. You can look at both of them. But either way, we're talking about making decisions. And in programming code, when we make decisions, we use if statements. We can use other kinds of statements too. So we don't call this chapter if statements. We call it selection structures, because those structures could be things besides if statements. They're selection structures because we use decisions to decide what code to select for execution. Now, there are really three types. A single alternative if statement is where we only have an if statement. There's only one alternative. If this is true, execute this code. That's it. Now, sometimes we want to do one thing if some code is true and something else if the code is false. In that case, we'd use an if statement with an else clause, and that would give us two alternatives, the if true alternative and the if not true alternative. So that would be dual alternative. Now, our multiple alternatives are involved when we use an if-else if structure or a case switch statement. Whenever we're using a multiple if-then-else-ifs block or a switch case statement, we're checking for mutually exclusive conditions. That means I don't mix up conditions that could both be true, right? So I can't have a block of if-else statements unless only one thing is true. Here's my single alternative. How old are you? Well, I'll input your age, and if your age is greater than or equal to 18, I'll say, you can vote, and do some other things. Let's put that, this is really good pseudocode for this code. Let's put this code in Python. I'm going to open Replit, and I'm going to create a new Python Replit. And this is going to be lesson 6. I think I said we were doing lesson 6 last time. I'm going to check. Go back to our modules here. Getting us messed up. Yeah, lesson 6. I was in the right place. Just didn't trust myself. Okay, so this new Replit is going to be lesson 6, decision making. And let's just call it 1. Decision making 1. So in this Replit, we're not going to have a lot of code here to start out with. They wanted to get an age. So let's, first of all, put some comments in. Some if statements. We have an input module. That input module, they want us to get the age. And if the age is greater than 18, they want us to do something with it. So I'm going to have a global variable for our age. And I'm going to set that age equal to an integer. With the prompt, please enter your age. Now I'm going to leave my global statement out so that we can see what happens without it. I'm going to define my output module. And in my output module, I want to check if the age is greater than or equal to 18. Now, this is how a Python if statement is formatted. First of all, we have variables that we can use in if statements. We have literals like this number 18. We could have a string within double quotes. So we can compare whatever we want. We use the standard comparison operators, greater than, equal to, less than. Now, if I wanted to check to see if something were equal to a value, I would use two equal signs because I have to make it different than where I set a value to a variable. So in this statement, line number 7 is an assignment statement. I'm assigning the value that the user inputs to the age variable. Here, I want to compare the age variable to see if it's greater than or equal to the value of 18. I put a colon after my comparison condition because the if statement has a body. So I wanted to print out something about them being over 18. Ah, you can vote. So good. Now I've got to execute both of these modules. Notice how this is getting to be, because we're using our modules, it's a little bit more involved than the pseudocode. I want to run my input module, and then I want to run my output module. Let's run this. I'm going to put in my age 20. That's really mad, isn't it? Look, it says that age is not defined. So here, when I updated it, it didn't update our global. I have to put in that global statement. Let's see if that fixes everything. Now our output module should know what our age is because we said we're updating a global variable. Ah, better. Everything looks happy now. So that silly global statement is important. Now in Python, we wouldn't need to have these as modules. I could just have these 3 lines of code, line 8, line 11, and line 12. That would be enough for me to have as a Python program. But I want to show you guys how to use the different modules so that it makes more sense. That way, things are structured. So that's a single alternative if statement. We're going to look at some more, don't worry. Now, a dual alternative is where we want to add an else statement. So we could say something like, else, you're too young. You're not old enough to vote. So let's add that to our Python program. We can put that in our output module with our same if statement. We backspace so that we're back at the exact same indentation level of our matching if statement. So this else statement has to have a matching if statement. If it doesn't have a matching if statement, it's an invalid else statement.
The colon for the else statement, is that is to signify that's the last step in the if else chain?
It's just to signify that this statement has a body.
Okay.
So it doesn't really tie it back to the if statement. The actual if and else statements are what have to be tied to each other.
Got it.
We'll try to run some more too. So now we've got our dual alternative. We're saying one alternative, they're over 18. The other alternative, they're under. So let's run this. If we enter 20, we should still get the same message. We have to test both ways. But now, if I do 16, I should see my other message, too young. So that looks good. Everybody's work okay?
Yep.
Good. Okay, good. So that's a dual alternative if statement. It's really hard to remember some of this to pass the written tests because hands-on, you know you have an if statement and an else clause. It's kind of hard to think of them as single alternative and dual alternative. So that's why I keep saying that, because I know that it's kind of a concept naming that is in word only. It doesn't really apply to our hands-on stuff. Okay, so dual alternative. Cool. Here's flowcharts. We saw flowcharts that did if statements when we were looking at flowcharts, but now we actually see that in our code. So here's our if structure. We have our decision diamond. Is our condition true? If so, execute the stuff. If not, bypass the stuff. So we, in our single alternative, we only execute our body of our if statement if the if statement is true. In our dual alternative, we have code that executes if the decision is true, and we have code that executes if the decision is false. Now, what if we have multiple situations, like we want to check for many different ages? Well, there's a couple of different ways that we can implement that.
One of them would be a switch statement.
Yeah, a switch statement. And Python doesn't actually have a switch statement. So it's good to keep that in your head because it's important to remember that this is something that's available in other languages. But Python itself, the people, the open source creators of Python, nobody has thought that it was worth creating a switch case statement for Python. But if I were using C# or Java or many other programming languages, I would have a select statement that says, select my code. And then I would have, in the case it's 1, execute this body. In the case that code's value is 2, execute this code. So we can have a select case statement or a switch case statement that is very efficient. So it's really important to remember that the syntax exists because it's very efficient code. It's just not something that we can do in Python. So we'll do multiple alternatives by using an if-else structure. Now, some rules, though, before we go into that. Remember, you don't have to have an else. Sometimes we only want to do something if something is true, and that's okay. So we don't have to manufacture any sort of alternative condition. Whenever you're working with an if statement, the body of the if is executed if and only if the condition is true. Otherwise, nothing happens. And with Python, I don't have to worry about you indenting for readability. That's Python, of course. Okay, so here's 2 ways. Both situations, we're asking if there are any children. In this first example, we're checking to see if the response is equal to Y. If it is, we ask how many children and input that number. Now, the alternative is we could say if the response is not N, then ask how many. Think about that. How are these two code choices going to differ? What would happen if somebody typed a Q? If they typed a Q in the first condition, nothing would happen, right? If they typed a Q in the second condition, that would not be an N, so they would get the how many children question. So that's fine. Just be aware that you have that choice in how you set your logic. You had two ways or more. Now here's a multiple alternative where we're looking at an amount. This is somewhat similar to the Python assignment that you have for a positive negative program. Here the pseudocode says enter the total cost, enter the total revenue, set our amount equal to the revenue minus the cost, and if that amount is greater than 0, then we have profit. Otherwise, we have a loss. So again, we can see that we do one thing if the if statement is true, we do something else if the if statement is false. Now, when we're doing decision making, the big thing is setting up our condition, and those conditions can be really involved. So if we look at the code that we have so far, we didn't have a really involved condition, did we? You wouldn't believe how many people can't remember whether the greater than or the less than symbol, which direction they point. So if that's something that you have trouble with, that's okay. Remember, the big side points to the bigger side of the if statement. So this is age greater than or equal to, meaning the bigger side is to the left. So by adding the equal sign, I'm kind of saying if it's greater than 18 or equal to 18 and getting both of those conditions covered. So that is my operator to determine what the relationship is between the two halves of my if condition. Again, two equal signs means is the same as. A exclamation point equals or bang equals is not the same as. We have less than, greater than, less than or equal, greater than or equal. Those are our relational operators. We use those to determine what the relationship is between the two halves of our decision. Here's some examples. This is a good one. So we have two variables, A and B. A is equal to 9, B is equal to 6. If that's true, then this statement can be read if it is true that the value of variable A is greater than the value of variable B, then write the value of B to the screen. So based on this output and these variable values, we would get this message, 9 is greater than 6. So perfect. Now let's look at these. If A is a value of 23 and B is 16, then this comparison is A greater than B. Yes, that's true. Is A less than B? No, A is greater, so that's false. Is A greater than or equal to? Yes. Is A less than or equal to? No. Is A not equal B? Well, that's true. Is A equal to B? No. So notice how when we're looking at these comparisons, we're going to replace the value of our variable with its value and then compare them. Hang on just a sec. I think my husband's home from the frozen tundra. Just a minute. Okay, I warned him that we're still in class. So we won't do anything crazy. All right, so that's what we do when we're looking at those comparisons. I already mentioned this, 1 equal sign assigns a value, 2 equal signs is the comparison. So if I tried this, where I have set A equal to 14 and B equal to 27, and then I tried to compare the two of them using only 1 equal sign, I would actually be changing the value of A and making it be the same as the value of B. Because 1 equal sign is an assignment operator, 2 equal signs is a comparison operator. Now again, here's 2 ways to consider the same kind of comparison. Take a look. On the left, we're seeing if a number is greater than or equal to 0. If the number is greater than or equal to 0, then we write it out. Otherwise, we subtract this number from some big number. Now, on this side, we have the if statement, if number less than 0. If the number is less than 0, we subtract it from some giant positive number. Otherwise, we write it out. So again, both are valid. We just have to do the right thing based on our logic, right? So notice how changing that comparison operator changes the effect of our if statement. We code it, we get to decide. All right, so here's one. If my age is greater than 16, then I could write out, you can drive. Otherwise, you're too young. But if my age is less than 16, I could write, sorry, you're too young. Otherwise, you can drive. What happens when they're 16 exactly? Which code would work properly?
The double equal sign, or greater than or equal to.
Which of the 2 that they give us? One of these would work, and which one would work? If you're 16. If my age variable is actually 16, this one would say, I'm too young, right?
Mm-hmm.
And this one would work. So that's the question. You don't get to change it to be greater than or equal. You get to figure out which one would work based on what they are. But you're right, changing it to the greater than or equal would solve
This seems like one of those math situations where they're like, you have to memorize all these formulas, even though in real life you can have it written down at your desk.
Either one of them would work. They'll all work just fine. But if you got stuck with somebody else's code, then you've got to figure out what it would do. Because we can't just change it till we know what it's doing. So yeah, it is. It's just like that. Sometimes people can just make the biggest, messiest if statements. And you want to simplify them, but you have to be really careful because you can change the intention very easily. Because we could take all of these operators, like the greater than and less than, and we can combine them together to make compound conditions. So we can take something that wasn't too confusing, and then we can add another condition to it. So we can use and, or not. So let's look at this. Here we're reading in a variable x. If the value of x is less than 5, we're going to write out okay. If it's greater than 10, we're going to write out okay. So that first code over here on the left has two different if statements. We can be more efficient than that. We could write it with one if statement. So if we said if x less than 5 or x greater than 10, then it's okay. Now, notice some things about this. Notice we have to say x twice. In no programming language can we say if x less than 5 greater than 10. We have to say the whole condition, then the or, then the whole condition again. Does that make sense? You guys are going to leave x out on one side or the other and say, I don't know why it won't listen to me. Well, it's because we have to have both sides of the comparison for every decision. That makes sense?
Okay, I have a question about this.
Uh-huh.
So physically, we would be capable of writing it out like that. So why is it made in such a way that it can't be done logically?
Because it can't be done logically, period, because we would have to make assumptions. If you write that way, you're assuming that you're still talking about X.
I see.
The computer is not going to make that.
Make the assumption. Got it.
So we have to be super careful because that's one place where we really tend to make that assumption. And it's hard for us to get down to the nuts and bolts of the programming language and realize you can't make that assumption.
Right. For us, contextually, it makes sense that they're still talking about X, but it is an assumption.
Right.
And the computer won't make an assumption because it's not able to.
Won't do it. And so you guys can, get together and add some open source Python stuff that adds assumptive decision, artificial intelligence type stuff. That's kind of what you're getting into, thinking that, well, I should be able to, because theoretically that's absolutely true, that we should be able to combine those sort of things. And so you could definitely write some code where you would be able to get away with things a little bit differently. But our native language, we have to have two complete conditions joined by this logical operator. So here's an and condition. Notice how it's different than the or condition. For the or condition, we were saying x is less than 5 or greater than 10. So the only place that this was not going to be true was if x was 5 to 10, right? Those numbers inclusive, including 5 and 10, would not show true on this or condition. But if I change it and I make it an and condition, I can kind of totally change the whole outlook. And now it's only going to be true for 6, 7, 8, and 9. If x is greater than 5 and x is less than 10. So notice how the or condition and the and condition change the whole context of the comparison. With an or, if either side is true, the condition is true. With an and, both comparisons must be true for the condition to be true. So here's another or. Here we're asking a user to enter a Y if they want to continue with something. And we don't care whether they enter an uppercase Y or a lowercase y. Well, in that case, we could check to see if the response is an uppercase Y or a lowercase y.
Can we go back to the
Sure.
and condition? Well, just specifically that example.
Uh-huh.
So like in SQL, there's a between condition, which is what
Right.
we would use for that. Because again, going strictly logically, it's not possible for the value of x to be both less than 5 and greater than 5 simultaneously.
Right.
So 6, 7, and 8 wouldn't work, or 6, 7, 8, and 9 wouldn't work either, because it can't be both at the same time.
Yes, it can. It is greater than 5. 6 is. 7
I
is.
apologize.
8 is.
Never mind. I was thinking on either side.
No,
in the
that's
opposite direction.
no. I'm glad you're looking at it that close. Totally, because it's just sometimes you've got to think about it based on the other stuff that you have experience with. So that's good. So yeah, in our or condition, you guys probably have other experience too, where some of you might be thinking, why we could just make it a lowercase letter or an uppercase letter, and that's true too. But we could use this or condition also. And then the not operator, it's a real pain in the neck. So I kind of have this rule. You should not use not, right? Isn't that cute? And you really should only use not if it's the logically correct thing to do. And every once in a while it is. You know, if something is not done or, you know, not out of time or whatever you're checking for, sometimes the not condition is logical. But in this kind of condition, it's a little messy. Here we're saying we have A and B. And if A is less than B, this condition will evaluate to true. But the not operator then will change it to false. If this condition evaluated to false, the not operator would switch it to true. So it can definitely be a very confusing thing to work with in somebody else's code. Let's look at this example. If X is greater than 100 and not X equal to Y, this is true if X is greater than 100, but not equal to the value of Y. So that one, you know, it makes sense. That not operator is not causing too much trouble. But anytime we get into negatives like that, it's like a true-false test. You know how if you're taking a true-false exam and they have a lot of not words in the questions, it just makes it doubly hard to be sure you're correct. And that's how it is when we're interpreting someone else's code. That not operator can really make things a little bit more complicated. So here's a truth table. A truth table, when you look at it at first, doesn't make a lot of sense. But it says we have a variable named X, and it's a Boolean, so it can either be equal to true or false. Next, we have a variable named Y. Whoops. I didn't mean to click. And it can either be equal to true or false. It's also a Boolean. So if X was true and Y is true, then the comparison X or Y would be true. The comparison X and Y would be true. And the only comparison that could result in any sort of false condition would be a not. Now, if we switch things and X is true but Y is false, then if X or Y would still be true. But now our and condition, if X and Y is false, because we can't have that be both of them. And are not X, because X is true, or not X would be false. Now, if we have one true, one false, we're going to get these outcomes, true, false. If both X and both Y are both false, then our or condition will finally be false. So notice, looking at this truth table, that an or condition is true if either side is true. The only way an or condition is false is if both halves, both sides are false. A true is the opposite. An and is the opposite, where the only way the and condition evaluates to true is if both sides are true. So the truth table, these two columns are the important thing. Or will always evaluate to true unless it's truly false. And will always evaluate to false unless it's truly true. Here's some good hints. Here's our hint about not abbreviating. We can't have x less than 5 or greater than 10. But we have to have it this way. And here's a really important one. We'll do this pay rate in our Python code because it's on all the exams. Let me see how much we have left here. Hang on, I think we're close to the end. Yeah, we're in at about the middle. So let's close out of this presentation at this point and add a few more if statements in our code before we're done. And I want to look at this pay rate. So let me go back to my Python code. I'm going to end this. And try to get that to Python. Okay, so let's look at our output module a little bit more. We said that if they're over 18, they can vote, but we have some other things that we've found out too. If they're not greater than or equal to 18, we could check to see if they're greater than or equal to 16, right? And if they're greater than or equal to 16, we could print out over 16, you can drive. Now, I want to point out these else statements. And hang on, I'm going to put that like that. Now let's take a look at what we have here. What I have is a nested if statement, but my nested if statement is under my else clause. So in our code so far, we've said if their age is greater than or equal to 18, we're going to say over 18, you can vote, yay. Otherwise, if their age is over 16, we'll print out, oh, yay, you're over 16, you can drive. Otherwise, we'll print under 16, and then we'll print under 18, too young to vote. So let's fix this one under 16, too young to drive. Okay, so now we have a nested if statement. Let's run it. Please enter your age. I'm going to say I am 20. So I should get the over 18, you can vote message. Good. Now, just like the replit, running another test, I'm going to run again. I'm going to do 18. Is that what I did? Run it again. Let's try 17. That's what I want. 17, I should get over 16, you can drive. Under 18, too young to vote. That looks right. Now let's run it again. I'll be 15 this time. Oop, too young to drive and too young to vote. So that came out all right. Looks good, doesn't it? Let's see. We could add in a 21. Let's put that in. I'm going to put that down here. If age greater than or equal to 21, let's print over 21. You can, well, you know what they can do. They can drink. Great, and let's put an else statement in. Let's print under 21 to
That
Now-
won't show up, right?
right. Why is that?
Because it's under the else clause for under 18.
And
Or
so,
for not over 18, not equal
yeah,
to.
let's run it and show everybody what you're saying, because you're absolutely right. So if I put in 22, the first if statement, if they're greater than or 18, is true. So it never gets down to my else clause to check to see if they're 21. I always have to check my most exclusive value, I guess we would say, first. Since I'm doing a greater than comparison, I would need to check for my largest condition first. So let's fix this thing. It's all kind of messy right now. I'm going to comment this out because I want to redo it in a different way so that you guys can think about it. So 1, 2, 3. And I'm going to put 3 down here at the bottom. That's messy code now. Now let's do it for real. I got to indent. So I'm going to say if age greater than or equal to 21, I want to print out over 21, you can. And then I'm going to add an elif. An elif in Python says else if the age is greater than or equal to 18. It did something weird. Replit is not indenting properly. I'm going to print over 18. You can vote. If my age is greater than or equal to 16.
You need to indent again. It
Yeah.
did it again.
It's not indenting for me. Over 16, you can drive. Let me indent this here. Now, finally, I can do my final else clause, and I don't have to have this, but if I do, it's only going to execute this else clause if all of those other ifs are false. We'll print too young. Now, notice that in this else clause, I'm not going to be able to differentiate and say, you're too young to drive, you're too young to vote, all of those different things, because I've created this multiple selection scenario here. Let's run this and make sure this syntax is okay, since I had to indent manually. Oh, it's all mad at me.
So I think what it is it indents as if you're going to make a second statement under the if until you type elif, and then it backs it up, except you backed it up before you typed elif, and then it backed up again when you typed it.
Is it? It's actually this comment block.
Really?
Makes me all mad. And I think that was what was causing my indentation problems too. But let's see if that's true. What it hates having a comment block right at the beginning of a function definition. And I don't know why it's so picky about that, but see if that takes care of it. Because I'm going to try 22. I got my over 21. I'm going to do 18. Got my vote. And finally, if we do 15, should get too young. Okay, so sorry about that. Yeah, it was me trying to make that comment block. Just got the Python interpreter all confused. So I just moved it down after our if elif block. So does that make sense? Notice on this multiple selection, My ELIF requires a condition. I can't just say ELIF colon. I can only do that with the else clause. The else clause is the only part of the if structure that doesn't require a condition. Now, I said I wanted to look at that overtime one. I think we have time. So it's really quick. Let's close this replet and create a new one. And let's call this L06 overtime pay. And this one, we're just going to put almost exactly what the presentation has. They say we have two variables, pay rate, let's set it equal to 15, and hours. And I'll set our hours equal to 45. Now, when I do that, I'm hard coding the test data in our program. So if I want to change the test data, I'd have to change those values. And that's okay, because I just want to test this if statement. So the way overtime pay works is, if you work more than 40 hours a week, you're supposed to get time and a half. Time and a half should be your normal pay rate plus 50%. So if I make $18 an hour, that would be 18 plus 9. I should get $27 an hour. Is that right? 25. I can't do math for the hours over 40. Well, in our scenario, they only get overtime if their pay rate is greater than or equal to 10, or their hours is they only want the people under $10 an hour to get paid for pay time and a half over 40 hours. So see if I can say that wrong enough ways. If their pay is over $10 an hour, or they worked for 40 hours a week or less, their total pay is standard hours times their pay rate. If either of those or conditions are false, they make less than $10 an hour, or they worked more than 40, we're going to do this else clause. We're going to set OT hours equal to the hours they worked minus 40. OT pay equal to our OT hours times 1.5 times their pay rate. I'm going to put parentheses around that time and a half rate to make me feel better, even though it would work properly without them. And then finally, I'm going to calculate my total pay is equal to 40 times the normal pay rate plus time pay I just calculated. So this person should make more. Then we're going to print their total pay. So let's try running this. What I did is I just directly interpreted the pseudocode into this if statement, and then I set my variables to values that I wanted to use for test data. So this person, hours is greater than 40, but their pay rate is greater than 10. So what should happen? The pay rate is greater than 10 is true. Hours less than 40 is false. So we should get just a regular pay calculation. Let's run it and see. Oh, that looks good. Now, what if I make their pay $10? I'm going to run it. Now, in that case, my pay rate was greater than or equal to 10, so I use the regular pay formula. Let's set their pay rate to 9 so that this if statement is not true. Should be going through that other formula. We can verify it by going to that Python tutor site.
Base.
Code. I like to see it. Let's run it. This one is a good one for Python tutor because we're just looking at these variables. So my if statement, this half is false. The pay rate is not greater than or equal to 10. Is the hours less than or equal to 40? No. So we shouldn't execute line 6. And sure enough, we bypass that and do our else clause and go through our overtime pay calculation. So I like that one better in the Python tutor because it makes a lot more sense if we can just step through our code there. And I wanted to go through this one because this question is one that they include in the test bank in our test questions. All right, we are almost out of time, and I know we usually haven't run out of our time. So I apologize, we had a little bit extra to do today. You guys, I'm going to leave that due date is tonight for that supermarket because I don't want anybody to put it off, but I won't assess a late penalty on it until the weekend. So try to get that done today. It is when you're supposed to work on with your group. So some of you may not be able to work on it because your group isn't here. Any questions before we end? We did a lot today. So you have a lot to take with you moving forward to go into that if statement chapter. Really be thinking about those questions that you've had. They've been really good. Okay, if there's no questions, I'm going to end our session. Everybody okay? Okay, stay warm. Have a good weekend. See you next week.